So first of all, thank you for having me. My name is Tom Janssens. You can find me on Twitter by Toyans. And this is a talk about common Ddd pitfalls. And as I was talking to the man in the back earlier, he told me I should probably give a small introduction about what DDD actually is. Because a lot of people heard about the term, but they're not really familiar. So DDD, Domain Driven Design, is actually something that has been coined. It's a book written by Eric Evans, and it's about tackling complexity in the heart of software. That's actually the subtitle. So let me just go to the next slide. So why do people do DDD? It's actually because when you're writing software, you start off with this huge, big pile of software, and everything's just then attached, and everything doesn't work out. You need to change something that impacts all the other parts of your application. So what Eric Evans actually did is he wrote a book which describes how you can properly divide your software, how you can model it, how the naming is important. It's really a really big book. There's lots of stuff in there. It's about tactical patterns. It's about strategic patterns. So strategic is how many subsystems are there in my model, how do they relate to each other. For example, if you have an invoice system and you have a system where users are connected, do the users actually require the invoice system to be available or not? Usually they don't, so you try to separate those stuff. Why I'm giving this talk is because I've seen a lot of people doing DDD. And there's quite some problems that you notice, and a lot of it comes from making mistakes. I've made a lot of mistakes. Who here hasn't made any mistakes during software development? Okay. Who here has made mistakes? Okay, so it's quite an interactive crowd, which is good. Let me just start off with the talk. So first of all, there's different areas this talk will be about. The first one is about strategic design. This is the thing we did in the workshop earlier. We tried to find boundaries within our application. We tried to find out which are subsystems, things that belong together. Might be transactional boundaries, it might be things where the language is consistent. There's a lot of possibilities here. Okay. I was talking too loud? Okay. And the next thing, can everybody still hear me now? Okay, so the next thing we have is tactical modeling. Tactical is actually just about how you technically implement the parts of your system. Then we have the next part, which is infrastructure. When you're actually molding everything together, you need infrastructure. The next part is selling it, because a lot of people, they discover DDD and they try to sell it to their colleagues. And they say, it doesn't work, nobody wants it. What do I need to do with this? I need another way to figure this out. And then, of course, the last part will be some general tips on how to do it. First things first, Bonnet Context. So the thing I explained earlier about Bonnet Context was about how your software is actually divided into different parts. I'm sorry. Yeah, no worries. Is that better? Should I take a little bit more silent? Yeah, okay. So as you can see, there's a thing called Lego City, which contains a big box, but actually, if you look at it, probably all the plans for this are packed together, and yeah, that doesn't work at all, so I'll just drop it here. Oh, it's okay. All the plans are packed together, all the stones are packed together, for this as well, and you do see some things crossing the boundaries. So sometimes something goes from this to there, which is just like in a real application. The thing is, of course, when you design your stuff, you want to make sure that these boundaries are explicit and that not a lot of things are crossing over. I hope everybody understands the main idea behind the whole strategic patterns. So you just try to divide your software. Is there anybody who says that doesn't make sense at all to me? Please explain it again or another way. Okay. So the first thing that happens that a lot of people tend to do is they start reading the Blue Book, and the Blue Book is the DDD book by Eric Evans. And this is a book that actually contains, 16, 17, 20 chapters, I don't know how many. And when people start reading it, they tell you first have to read chapter 1 to 3, and then you have to read chapter 11 to 13, and then you have to go back to the other one, so it's really a mess. So what people usually do is they just skip all the thing about modeling your bounded context and they just go to the core, which says, okay, how can I actually implement this using repositories, using aggregates, etc., etc. Who here is familiar with the term repository? I'm assuming all of you, yes. Aggregates, also quite a lot. Events, yeah, I know, some follow the workshop, so. So the thing is, of course, what happens when you ignore bounded context? You get this, which is really a big pile, which you cannot do anything, because if you want to take this, the whole thing falls apart. If you want to take this, the whole thing falls apart. When you have this application that you want to change, and you're afraid of changing something, because when you change the ordering, the invoicing might actually fail, which is what happens if you don't have proper boundaries. That's a really important part. Just one thing, because I don't know on the time. We're probably 5 minutes in. The next thing is Conway's law. Who here has heard of Conway's law? About half of you. Who here knows the formula of Conway's law? N times n minus 1. What is it about? Can somebody explain it to me, or should I explain it? Yeah, I'll explain it. Okay. Conway's law is actually about how you have teams communicating and how many communication channels there are. So if it's just two people communicating with each other, it's 2 times 1, it's 2 channels. If you had 3 people communicating with each other, oh, sorry, there's already a lot more channels, because it's 2 times 3. I just need to make sure. So the thing is, of course, Conway also states that when you build a system, it kind of works like your software teams are put together. So if you have a software team that works somewhere in India, you have another software team that works in Croatia, and you have one software team that works in France or in Belgium or whatever, your software will probably also be divided by those boundaries. So the thing that you need to understand is that you model your software according to the way your organization works. Every single organization has a different point of view, so you have to make sure that you understand, okay, this is the way they look at it, this is the way that they look at it. If you don't respect that, if you don't understand the whole thing, then that might seem a little bit odd, but you tend to mix up a lot of things and cross boundaries that you shouldn't cross. Does this make any sense to anyone? To no one? Okay, that's great. So the thing is, you have to really be careful when you model something that you actually mimic reality as well. And then there's who knows what a Gedanken experiment is? It's a German term, yeah, there's a guy over there. Who knows what a theoretical physicist is? So Albert Einstein, I'm assuming you know who Albert Einstein is. Yeah, okay, I assume that. He was actually a theoretical physicist. So instead of experimenting and taking apples and making them roll down the hill and measuring the time that they took, he just thought about what would happen if. So one of his famous experiments is when he was thinking, what would happen, because the speed of light is constant, what would happen if I would be on a rocket that travels on the speed of light? Would I see the light that's behind me, that is generated by the rocket? Just by thinking about like that, he built up the whole model. So he didn't actually went and tested something, which they only did recently, a couple of 10 years ago. But he actually was thinking about, okay, how does this work? How does that work? How can I find it out? This is really important in software as well. When you try to determine your boundaries in strategic modeling, the thing we did with event storming earlier for the people who were attending is really important. Because when you do it with Post-it, it costs you like 20 minutes, half an hour. And you can just throw it away, start over again, etc., etc. When you do it in code, however, you have a big problem. If you start implementing stuff, you work for it, let's say, for 2 months or something with 4 people, and all of a sudden you realize, oh, this boundary is missing. I actually need to make that, to convert it into 2 systems. It's really, really expensive. So the thing is, the thing we're trying to sell with model storming as well is you really need to experiment with your model, with your software model, in your mind, using Post-its, using mock-ups, using use cases, whatever you can imagine, personas, documents, anything that might work for you. Because that's really cheap. But once you start implementing it in code, you have big issues. It's really expensive. And then the next thing is the lack of a domain expert. So I think some of you noticed in the workshop earlier that we followed if you have to write code and you don't have the possibility to ask somebody how does this actually work, it's really hard. It's really, really hard. You have to not only make assumptions about how the systems work, but also how they are named. You tend to miss edge cases, you tend to miss the overview. So you should actually make sure that you have a domain expert, because otherwise it's just guessing. You might as well just take, what do you call it, a dice, I think, and just throw it. And then, some things that work, what's really important here is this, this sign, which is actually n equals 1. So the statistical relevance is actually 1. This works for me. I'm not saying it will work for you, but it might. So when I think about Bonnet Context, I try to find a lot of point of views. I try to figure out use cases, personas, whatever might work for me, whatever might happen. I tend to have as many Bonnet contexts as possible. So I try to find the smallest Bonnet context possible. It has some disadvantages. They're mentioned in the blue book. You do have some overhead. There might be more contracts crossing boundaries. But that's something I really prepare. I rarely see Bonnet contexts that are too big, that are too small. I usually see them too big. Which is again important, because then everything gets impacted, which brings us to this, up and downstream. So the term up and downstream is actually something that is also mentioned in the book. It's about relationships between bounded context. So you know the bounded context, which was this part of Lego City, this part and this part. The up and downstream actually describes the data that flows between those several bounded contexts. People call that domain events usually. That's one way of looking at it, and it depends, of course. You have other relationships as well, but usually it's about domain events or about models calling other models, just invoking things, etc. So I try to have as little contracts as possible, because the more contracts you add, the more noise you add, the more you create dependencies, etc. This is not the same, so I try to have as less contracts as possible, but there can be a lot of bandwidth. So a lot of messages can go through, but they shouldn't all be of, there shouldn't be gazillion of types going around there of different messages. And also try to think about dependencies. What happens when a system goes down? If one part of your bounded context goes down, should the other things still work or not? Those are usually things that people tend to forget. It's really important. Or when you change something, you deploy something, you might have to say, I need to deploy this, but then I also have to deploy the front end, and that has a lot of extra impact. Actually, not the front end, that's a bad example, but you really need to think this through. Any questions so far? Am I talking too loud? Just to make sure. Is this going fast or slow, or who says it's okay? Just do like this, Roman vote. This is, okay. Thank you. So, on to the next part, the tactical patterns. So once you've defined your boundaries, you remember the Lego City things, you actually start implementing those little parts. You can do that using repositories, aggregates. All these things are described in the blue book. The first things first, you shouldn't use DDD for non-core domains. Who here has an idea what a core domain means? Okay, does anybody care to explain, or should I explain it? Just to make some... Cyril?
Usually the core domain is what's differentiating in your business for your company, for instance.
That's perfect. So what you actually do is, for example, when you have a company, you tend to do a lot of things like the same way other people do. For example, invoicing, etc., etc. But when you're a company that does transport, that handles transport, you try to make sure that you're ahead of the competition in the part that does the actual transport, that part of the software. Which is what Cyril said, that you actually try to make sure that you use DDD for core domains, because if you use it for non-core domains, you tend to have a lot of overhead for it, because there is some overhead attached if you do DDD, and you create something like this. So this works, it's fine, but there's a lot of work to add all these Lego blocks on top of just to replace something. And it's not really perfect. So my advice would be, it's all personal advice that I'm giving, so my advice would be, okay, if you have all these bounded contexts, really be careful and think, where do I want to invest? Other things you might really want to buy from the stock, from I don't know, somewhere else. You can actually buy a lot of parts of the Bonnet Context, a lot of software parts. You can actually buy them. And it's really easy because then you don't have to spend your time there. You can really focus on what differentiates you from the other guys. So far, so good? Okay. Next part. What happens when you ignore some aspects? Usually, people tend to start from the data point of view, which we also did in the workshop earlier. So you start by, okay, let's see. We have a shopping cart. What else do we have? We have orders, we have items, we have customers, etc., etc. You're starting from the entities. But you shouldn't only do that. You should also start from behavior. Behavior is, okay, what happens if I do this? What happens if I do that? And you try to model that as well. So what's really important is that you don't build a too cruddy interface, but that you don't overdo it on the other way as well. The first thing I did when I discovered event storming is I started using event storming everywhere. I said, oh, this is great, and this is wonderful, and we have this huge model, but I was applying it to data solutions as well, which wasn't exactly great because you should really consider all the possible options and you shouldn't ignore anything. Ignorance is bliss, but it might bite you in the ass. So, okay. So the thing about repositories exposing state. A repository, is there anybody who cares to tell what a repository is?
Storage for your aggregates.
Okay, storage for aggregates, which is really important. He's talking about storage for his aggregates. He's not talking about storage to populate his views on the screen or something, view models, etc. He's talking about storage for your aggregates. Why is that important? If you don't do that, if you say, I'm using the same repository for both my domain model and I'll use it as well for my screens, etc., etc., you start really polluting your model, your repositories. Repositories should only contain the language of the business. So what happens when you expose state, you're not supposed to do that. I know it's not readable, but you try to be, for the other guys, you try to be, yeah, I'm all polite and stuff and things like that. The inside, that's something you want to hide typically. So you better not talk about that. Okay. This is actually a Belgian comic guy. It might be that the humor is very Belgian specific, so don't be offended by anything. Is everybody still awake? Yeah, okay. Okay, another thing is tell, don't ask. What I see a lot in some repositories is they have this generic repository where they can just give me all the users, and they apply queries on top of that, etc., etc. That doesn't work well for domain-driven design. Why not? Well, if you, for example, if you want to find out if a customer is a VIP customer, you actually have to get the customer in, you have to check some fields, you might have to check his balance, you might have to do this and that and that and that. What I usually do is I just build a repository that has a function is VIP that just passes the ID of the customer, is VIP, which is really nice because then when you look at your code, it's only if he is a VIP, if repo is VIP, that customer ID, then do this, do that, do that. So it's all about tell, don't ask. It's a really known principle. It adheres to the solid principles. You should really respect that. You shouldn't overdo it, of course. I don't know if you know the overly annoying girlfriend, attached girlfriend. Yeah, she's annoying as well, but so you shouldn't overdo it. I've actually seen code where your domain code was actually just like 3 lines, and that was it because everything was handled on the SQL backend. The logic should still be visible in the domain code itself, in the aggregate code. I hope this is not too theoretical because I don't know how big your base is in domain-driven design. Have I mentioned anything that sounds odd or that sounds strange to anyone? No, everybody's like, I'm not going to say anyone. Okay, nobody. The next thing, so when you got your tactical and strategical patterns in place, you say, I need infrastructure. So what do people usually do? They start building infrastructure. And I say, yeah, we need event sourcing, we need SQL, we need caching, we need this, we need that, we need lots of stuff. So this is usually what you build when you get started. I tend to do it the other way around. I tend to start without architecture because this is usually what you need. So there's a big difference. People tend to build all this stuff because they assume, yeah, in the future somewhere I might need this. You don't want that. You actually want to have something like this, which is really simple and clean and elegant. It might take some more effort, but I'm a big, not opponent, but the other way around. Help me, please.
Big proponent.
Excuse me?
Proponent.
Proponent? Is that the other way around? Oh, I didn't know that. I'm a big proponent of having things that are simple. They don't have to be easy, so I might have to add a few lines of code. But I tend to prefer simple over easy. Because in the long run, simple usually works way better if you have to maintain stuff. Writing it, it's like when you create a drag and drop application. It's really easy to do that. And then afterwards, you have to change it. And you're like, oh man, I'll just rebuild it. Because otherwise it's a big mess and I will never touch it. Which is why I say always opt for simple and not for easy. I hope the distinction is clear. Another thing that's important is framework versus libraries. There's this cartoon from Explosion that actually shows it pretty good. Which is he has to respect the rules of the system, but then he bends it. So he actually determines the rules of the system. Is there anyone who can tell me the difference between a framework and a library? The essential difference? Oh, sorry, yeah. Go ahead, I'll take the guy in front because everybody might hear.
So a library is a set of functionality where a framework brings functionality but also a way to work.
Yeah. I think that's basically it. So it's about who is in charge. So a framework calls your code and you call library code. That's basically it. Do we agree? Yeah. And what's really important is try to use frameworks only for established domains, for things like HTTP, stuff like that, technical stuff. I tend to avoid frameworks when I'm writing DDD code in my core domain because you start using these frameworks that really give you a lot of value. So it takes you 20% of the time to write 80% of the code. And then it takes you 160% of the time to write the remaining 20%. Which is like really, because you have to work around all the nags and the things that are in there. I tend to prefer libraries when I'm using non-established domains. Is there anybody who disagrees on this? Oh, it's a really interactive audience. So frameworks and libraries, what happens when you get this generic framework or library that does everything? This is what you get. Everybody's like, what? Or you actually end up, for example, when you're doing IOC using containers and stuff like that, and look at the container configuration, like, okay, it's time to get a coffee, I think. And I'll come back tomorrow and hope somebody else fixes it. So I try to avoid things that are too generic because the complexity is actually hidden inside here, inside user interface. So people they try to remove all the abstractions and all the complexity, but they just put it in another format. That's even worse than just having it in code. So, next thing, generic frameworks and libraries usually result in hacks. I've actually done this like a gazillion times, where I started, oh, well, let's use this and I'll use that, and then, oh, but that doesn't cooperate. I need to have a setter on there, and I'll just use. Maybe I can use a proxy to generate automatic setters, and you end up with something like this, which is like a huge mess, and it's just not elegant. So once again, it's about simple versus easy. Adding a proxy, a dynamic proxy, and just attaching some things on there, making code dynamic. It's really, really. How much time do we have left? No, it's really easy, but you want to make your code simple. Try to avoid hacks and things like, yeah, I'll fix it tomorrow, I'll do it when I have the time, because it usually bites you in the back when you have like no time. And there's this huge bug that's coming upon you and you're, fix it now and we don't have time. Another thing is, this is big in the event sourcing world. And I don't know how many people are actually using event sourcing, probably not a lot. 1, 2, 3. Yeah, I see 4 fingers, so you have to be really careful. Let me just define what eventual consistency is maybe first, just to make sure everybody gets it. It's about data not being updated in real time. The thing is, usually people are like, oh, I want my data only to be real time, but that doesn't exist. think about when the minute you launch your query to your SQL server and it starts giving data back, things might have changed. Even if it's real time, it might take microseconds or milliseconds, but you're never sure when some data leaves the context where it's consistent in. When some data leaves it, it might be inconsistent. So what happens when you have things that are not consistent? You get this weird kind of things, like for example, the Google car actually got this, which is probably because the cat was walking past, the cat first took this picture and then it took the picture of the back, and it results in something really odd. I'd like to have it actually, but would be fun, yeah. But you have to really consider when you're using eventual consistency, you are actually needed, because it tends to add a lot of complication as well. When people do event sourcing, they try to make things async, and they try to make it all go around and stuff. But you really have to understand what you're doing and wonder yourself, do I actually need it? Which basically brings me to the next slide. Anything, do you need it? This is actually an excerpt from Le Petit Prince, d'Antoine de Saint-Exupéry, but I'll go to someone else to read it. À vous l'honneur.
Il semble que la perfection soit atteinte non quand il n'y a plus rien à ajouter, mais quand il n'y a plus rien à retrancher.
Merci beaucoup. A small applause, please. Yeah. Yeah. So this is actually, I was bored to death with this book. We had to read it when we were like 17, and you can imagine when you're 17, that's not really the book you want to read. But there's a lot of value in there, actually. Nevertheless, I think this quote strikes it perfectly. When you try to build a system, you're like, oh, and we can use NuGet, and I'll add this package, and we can use JSON, and we can do that. And then in the end, you have like 30 dependencies, and you don't even recall, why did I actually include that one? Which is why you try to make sure that your code remains simple. You try to avoid easy stuff. You try to make sure that everything's pure and simple, and etc. Okay. Any questions so far? How am I doing with the time? Does anybody have an idea? 26 minutes in? 60 minutes left or in? Left. Oh, okay, left, okay. I think that's quite good. So once you get into this whole DDD thing, it's like, whoa, this whole world, it's like popsicles, and it's like, whoa, it's imaginary, and everybody loves you, and it's like in the 60s, basically. So, and then you go, okay, I want to use it at work. And you start talking to people, and they look at you like, what? What are you talking about? What ubiquitous language? What are you talking about? So selling DDD is tough. It's really tough. Actually, what you need to do is, this is a whole other talk. I actually gave this talk for the Belgian DDD community a little while ago. And it's a completely different presentation. But I'll show you the recap. So when you actually get into the whole DDD thing, this basically works for